All right, so here it is. Miles, Peter, Evan. So before, we might have asked this question, what is the sine of pi sixth? To which everyone says 1/2. The ratio of pi sixth is 1/2. Today we're going to start talking about the inverse trig functions, which is a lot like what Sam's question was, and Elizabeth said this at the very beginning of class. Use the inverse whatever tangent function, or whatever you were saying. And so now the question is this. Now, I want to introduce notation to you that you may have seen in geometry. Sine to the -1 is not the reciprocal function. It's not 1 over, and we talked about this when we talked about inverse functions, is the inverse sine function. To avoid confusion, some mathematicians write this question like this. They call it the arc sine function. And they say the same thing. So this question asks, hey, there's an angle out there that has a ratio of 1/2. What's the angle? To 30 degrees, or make sure you're in radians. Okay. 30 degrees or pi sixth. Now your calculator is never going to tell you pi sixths, right? Because it can't write that as a fraction. It'll give you some decimal approximation. Does anyone want to give me a different answer? No, you could say 30 degrees. What? Close, but not right. Your thinking is on the right path. You just picked the wrong angle because it's positive 1/2 and not negative 1/2. Nope. Evan? Nope. All right, so just to recap, Monty said 210 degrees has a sine of 1/2. Okay? He's wrong, but he's on the right track. Okay? And then Danny said 120, and now you said 150 degrees. That does have a sine of 1/2. So you could also say 150 is, in radians, 5 pi over 6. You could also say 13 pi sixths. You could also say 17 pi sixths. You could also say 25 pi sixths. We could actually go on and on and on. Sorry, what's your question? Rafi? You sure? So do you see how this is just these two angles are the same? It's just one went all the way around the circle once. And that's the same as this, except this went all the way around the circle once, twice, and a little bit. There's a problem, though, with this. And the problem is that that's not a function. How is that not a function? What's the problem? What are we used to with functions, and why does this seem to be a problem with that? Yeah. So Sam and Elizabeth say, your function has to only have one output. How confusing would a function be if you could give a whole ton of outputs for the same thing? It wouldn't work. So the inverse sine is a relation. Okay? We can talk about the inverse sine function, but when we talk about the inverse sine function, we have to be very, very careful about the domain that we talk about it on. So we'll save that for like another couple minutes, but let's just do a couple more of these because we're having a lot of fun. How about the arc cosine of root 2 over 2? Monty? 45 degrees, or pi over 4. Good. How about the inverse sine of 0. Monty calling someone for the inverse sine of 0.
So, 1.
No.
I mean, pi. I mean, 0.
It's 0.
Or 2 pi.
Or 2. Yeah. Or pi. Or 2 pi. Okay? Those would all work. Okay? So this asks, what sine has what angle has a value of 0? 0 does. Rafi, how about this one? Oh, you're doing so well. You got like the last two, like calling out. I thought I had a lock for sure. What angle has a sine of 1? Like think about your table. Which has the output of 1? Uh-huh. Give it to me in radians. Yeah. That's exact. I was waiting for her to say that. That's good. 2 pi over 4. Yeah, pi over 2. Good. All right. So we've turned this around. So the question now isn't what's the ratio. It's what's the angle, which means I can now ask you all that table backward now. Man, that's tough, Evan.
When asking for that, like going this way, does it have to be the inverse sine?
Yes, that's what says we're asking it backward. The two ways of saying that, Evan, are with this -1 or by putting arc in front of it. And that's the indication that we don't want the ratio, we want the angle. Okay? Okay. This one's going to be impossible.
That's no chill, bro.
I think so. Did you look at your table? Yeah, you did. It would not be 0. Keith says pi fourths. Can you explain why? I mean, I get that you looked at your great table, but why does pi fourths actually make sense?
Keith, why does it make sense, Keith?
All right, let's think it through a little bit. What is the sine of pi fourths? Root 2 over 2. What is the cosine of pi fourths? So what is the tangent of pi fourths? Was it sine over cosine? Or do you just have that memorized? One or the other. So if the tangent, what's the cotangent of pi fourths? It's also 1. So can you see that if you know this, that's this question backward? But can you see how much thought went into figuring out that was this question backward? It's harder to ask the question backward.
Wait, couldn't it also be like if it's 1 over 0?
Undefined.
Or 0 over 1?
0.
Oh.
It's got to be equal on top and bottom. So something x over x, whatever that is, and I happen to know that it's equal at 45 degrees. That's when sine and cosine are the same. Okay. All right. So you're going to have a host of questions that are sort of like this that I'm going to say don't use your calculator with on your homework. And then if you have to peek at your table or peek at your calculator, you can. Make sure you're in the right mode, radians or degrees. And then tomorrow we have to come back to this problem that we have. We have a problem that the arc sine of some angle, there's not one answer. There's an infinite number of answers. Just like the arc cotangent of 1, you could have said pi fourths, but you also could have said 5 pi fourths. And you could have said 9 pi fourths. There are actually there are an infinite number of answers there, and that's a bit of a problem. So we're going to focus on, I'm guessing you need to read the directions, but the answers between 0 and 2 pi. But then tomorrow we need to talk about, well, when are they functions and when are they not? And is there any way that we could actually talk about the inverse sine function as opposed to the inverse sine relation? All right, and that all goes back to the problem Elizabeth and Sam told us you need one output for every input with a function. You alright?
I really 5 pi over 4 pi over 4 is the same thing, just going around the circle.
So